Good morning everyone. This is Raghu, Assistant Professor, Department of Mechanical Engineering, Sri Ramakrishna Engineering College, Coimbatore. So today we are going to see the topic forecasting models in the subject Industrial Engineering and Cost Estimation. Let us get into the lecture. So what is forecasting? This forecasting is a tool. This is used for predicting the future demand based on the past demand information. So this forecasting will be good when the old data or the past data is accurate, and this forecasting is basically only upon the past which predicts the futures. So why we want to have this forecasting in industrial models is, in two cases we will be using this forecasting thing. One is in production scheduling and another one is in process control. Under the production scheduling, we will be predicting the demand for each product line for specific weeks and months, allowing the firm to plan production schedules and inventory maintenance. Whereas in case of process control, we will be using this forecast for the predicting the behavior of the industrial process in the future, so that the number of defective items produced can be minimized. Next we move on to the principles of forecasting. So this principles of forecasting tell us that the forecast will be more accurate when you have a large amount of data than for individual single datas. Then the forecast will be more accurate for the shorter terms, like if you take a 3 weeks or 3 months period, it will be accurate than the 5 weeks or 5 months periods. And also this forecast has to be calculated for the error estimate, because all the forecasts cannot be accurate when we compare to that demand. So we have different data for the actual demands. So this is January month, February, March, April, and it goes till August. So these are the past data which is here for the January, February, March, April, and goes till July. So we predict the demand looking back at the 6 different months. So orange color dot is indicating the actual demand. This is for the past sales. So depending upon the past sales, we are going to predict it for the July and the followed months like August, September, and all. So forecasting can be done for different time ranges. So we have 3 different time ranges. One is the short range forecast, and second one is medium range forecast, and third one is long range forecast. For the short range forecast, which is usually from 3 months and up to 1 year, which is used only for the purchasing, job scheduling, workforce levels, and job assignments and production levels. Whereas in case of medium range forecast, we will be using it for 3 months to 3 years, which we will be planning only for the sales and production planning and budgeting. And then for the long range forecast, it is for a maximum period level, that is 3+ years. We will be planning it for when the existing products becomes obsolete, we will be going for the new product planning, and for relocation of any facility and doing R&D, we will be planning for the long range forecast. Then we move on to the types of forecasting. So types of forecasting, we have 2 different methods. One is qualitative methods and second one is quantitative methods. In qualitative methods, it is totally based upon the judgmental based method, where we have collective opinions from different experts. They will be predicting based upon their experience. And for the quantitative methods, we will be predicting it with the numerical data and mathematical modeling. So under qualitative methods, we have 4 different categories. One is a jury of executive opinion, second one is Delphi method, third one is Salesforce composite, and fourth one is consumer market survey. In the first method, there will be a pool of experts. We will be getting the opinions from different experts and arriving at the solutions or arriving at the decisions makings. And second method, in Delphi method, here also we have different experts will be sitting in a panel. So we will be asking question to each and individual experts and consolidating all the answers from the experts. We will be arriving at the decisions. And the third one is Salesforce composite. We have a different sales force and they will be selling the products to the consumers at different locations. So we will be asking the opinions from that salesperson and consolidating the final decisions. And the fourth one is consumer market survey. We will be directly asking the customer, those who are looking for the how much demand is expected for the next month or next week or next year, and so. Next we move on to the quantitative methods. Under quantitative methods, we have 3 different methods. First one is time series, second one is causal relationship, and third one is simulation. The time series method is the most dominant method that will be used for predicting the future demand based on the past history trends. This is totally based upon the calculations on the numerical data. And second one is causal relationship. We will be using the statistical techniques to establish relationship between different items and the expected demand over it. And the third one is the simulation, which is used for complex cases, and when there is a more randomness in this trend of the data, we will be going for the simulation kind of thing. So today we are going to see specifically about the time series method, in which we have three different methods. The first method is moving average, and second one is a weighted average, and third one is smoothing average method. The first method is a relative and commonly used method that is used for developing a forecast for the past data. So here we will be using the different time periods in the past data and to predict the demand for the future data. So there will be two types under this time series moving average method. One is simple moving average, and second one is weighted moving average. So the moving average method is that most accurate prediction of the future demand is a simple linear combination of the past data. Suppose if we want to predict it for the 6 month, we will be taking the past 5 months data and calculate it for the 6 month. So under time series simple moving average method, it's simply calculating the averaging the demand data from the several of the most recent periods. So when the demand data does not have any rapid growth or seasonal characters, this technique can be useful. So if you look at it, so here we have the formula. So forecast for the next period, that is ft plus 1 equal to at plus at minus 1 plus it goes on at minus n divided by n. So this n represents the total number of forecasting horizon. That is, if you take it for the past data, how far we look beyond. If there is a 5 months data back, we will be taking it the n as n equal to 5 here. So if you look at for a 3 months period, it is n is equal to 3, and if you take it for 4 months period, it will be 4. So how much data that we are taking, that is the n here. So forecasting ft plus 1. So forecasting for the next period ft plus 1. So this is the forecast for the next period, and t represents the current period. So current data has to be there, like actual demand is there at. So this t represents the current time period, and actual demand has to be calculated for the previous demands. We will be forecasting for the next thing. Okay, here we can see the forecasting production of bolt or nut at shop floor. We have the data here. So for the different months, we are having the data over here. So this is for the January month 1325 and February month 1353. So it goes on till June. We have to predict it for the July month. So what will be sales for the July month? So that is a forecast that we have to calculate based upon the previous month's data. So we can take different months data, like if we even have 6 months past data, we can take it for 3 months simple moving average, or 4 months or 5 months kind of thing. So if you want to predict the forecast for the, so that is for the July month, if you want to predict with 3 months simple moving average, we have to take only the past 3 months data, that is June, May and April, divided by the number of months. If you are considering 3 months, it has to be divided by 3. So you calculate the demand for the next month, that is for the July month 1227. If you take 5 months simple moving average, you have to take the past 5 months data, June, May, April, March and February. So 5 months if you take, the n becomes 5, n equal to 5. If you take 4 months data, that is n is equal to 4. So you predict that 1268. So there is an increase in the demand forecast for the July month. If you take the 5 month moving average, if you take for the shorter period, it will be lesser forecast. So this forecast based upon the 3 months moving average and 5 month moving average, we have plotted it in the graph. So 0 to 8. So that is the here in y axis we have the forecast. So this is forecast, right? And here the point is over here. This is for the 3 months data, and this is for the 5 month data. There is an increase from 5 months. From 3 to 5 months, there is an increase in the forecast data, which means that the 5 month average smoothes the data more, and the 3 months average is more responsive because it is calculating for the recent data, so that is approachable. Okay, so we have another problem where we can take the question is asked us what are the 3 week and 6 week moving average forecast for the demand. Assuming you have only the 3 weeks and 6 weeks of actual demand data for the respective forecast. So we will be calculating the 4th month moving average by taking the demand from the past 3 months divided by 3. So this gives the values of 682.67, and for 6 months moving average, we will be taking the past 5 months data. So 1, 2, 3, 4, 5, we have to take it 650 plus 678, 720, it goes on till 5th month divided by 6. Okay, so you have to take the 6 months and calculate the 6 months average while calculating the 7th month average, so which is 768.7. So if you take for the recent month, like if you take for the 4 months forecast period, taking the past 3 months data, we will be giving a lesser value here, 682.67. If you take the 7th month forecast by taking the 6 months moving average, we will be giving a higher value. So this demand and forecast, actual demand has been plotted in red color line. So this gives the ups and downs, like it goes like this and dips and it goes up and goes. So there is not a smoothing behavior here, but when we predict it with us moving average method, we will be getting a yellow line. So this is 3 weeks demand average. So for every consecutive weeks you will be calculating a smoother line is followed. For the 6 weeks the line is still smoother than the 3 weeks, but this 3 weeks calculating, if you take for the shorter period range, it will be actually reacting very accurate to the recent data, but the 6 month average is very smoother, but it doesn't reacts very accurate to the recent data. So we can take it for the shorter periods, like 3 weeks period is better than the 6 weeks. So next we move on to the time series weighted moving average. In simple moving average, we will not be giving any kind of weight added to the recent data, but here we will be giving importance to some of the data that is very recent data will have more weightage. So here if you take certain things, the formula is similar to the previous thing, that is a simple moving average method. Here the formula is ft plus 1 equal to wt plus at. So here the new terms comes, that is the wt. So WT is what is WS is the importance weight we will be giving to the each period. So recent data will be giving to the more weightage. So as it is in the actual previous method, A is the actual sales figure for each period and N is the total forecasting horizon. Suppose if you are taking for the 3 months, it will be N will be 3, and if you are taking for the 5 months, it is N will be 5. So FT plus 1 as it is in the previous method, FT plus 1 is the forecast for the next period and T is the current period. Okay, T is the current period and T plus, if you put for T plus 1, that is for the next period. So we have simple moving average method. Why we want to have the weighted moving average methods? Because we should have the ability to give more importance to what happened recently, because that is going to affect the next data. That will be having the more impact on the next data. So that's why we are giving the weight to each and every data, and the recent data will be having the more weightage. Suppose if you are predicting 2 different methods, like if you take the simple moving average method and the weighted moving average method, the predicting will be different, right? So for the past data from Jan to June, there will be a demand is there, and you are predicting the forecast for the July month based upon the 2 methods. So using 2 methods, simple moving average, so this is a red color dot, and for the weighted moving average it is a blue color dot. So here the value is higher for simple moving average and the value is lower for the weighted moving average. So the decrease in the demand is predicted accurately by the weighted moving average, and the increase in the demand is predicted by the simple moving average. So we will be missing the downward trend if we don't give weightage like in the simple moving average. If you give the weightage to the weighted recent data, we will be predicting the downward trend that is going to affect the next month sales. So we can see the numerical problem here. Given the weekly demand and weights, what is the forecast for the 4th period or week? So T minus 1 we will be giving the weightage as 0.5. So in simple moving average we don't give any weightage here, but in weighted moving average we will be giving the weights T minus 1. T minus 1 is the recent data for the past month. 0.5 is given, okay, plus T minus 2, 0.3 plus, and T minus 3 is 0.2. So if you average it, it becomes 1. So the weightage for the previous data, if you sum up the weightage, it will be equal to 1. Okay. So now we look at the solving of this problem. We have 3 months data here. The first month data is 650, and second month is 678, and third month is 720. We have to calculate the forecast for the 4th month. So the weightage is different. For the T minus 1 is 0.5 and T minus 2 is 0.3 and T minus 3 is 0.2. So we have to give the higher weightage to the recent data. So 0.5 into 720 and 0.3 into 678 and 0.2 into 650, and you get the value of 693.4. that is the forecast for the 4th month data. So this is another problem. Given the weekly demand information weights, what is the weighted moving average forecast for the 5th period or 5th week? So we have 4 datas over here. So first week it is 820, second week it is 775, and third week is 680, and for 4th week it is 655. The different weights has been given as I told earlier. So here also the T minus 1 it is having the weightage of 0.7, and T minus 2 it is having 0.2, and T minus 3 it is 0.1. If you sum up 0.7 plus 0.2 plus 0.1, the total weightage should be it's equal to 1. Calculating the forecast for the 5th month, we will be giving weightage to the recent data. So 0.7 is the highest weightage that has been given to the recent data of the 4th month 655 plus 0.2 into 680 and 0.1 into 755. So we calculate the forecast as 672. So next we move on to the third method and the final method on the forecasting using the numerical data. So that is a simple moving average followed by weighted moving average, and finally we have the exponential smoothing method. Here one difference has been given because always the forecast cannot be accurate as to the actual data. So we have to give some smoothing constant in order to reduce the forecast error. The formula is Ft equal to Ft minus 1 plus alpha into a t minus 1 minus Ft minus 1. So as usual in the previous formulas, Ft is the forecast value for the coming t time period, and Ft minus 1 is forecast value in the past periods, and At minus 1 is actual occurrence in the past time period, and alpha is the smoothing constant which is used to reduce the error. We have to decrease the error that is calculated between the forecast value and demand value. So we have to bring it this alpha smoothing constant which reduces the error value. So we can see a numerical problem here. A firm uses simple exponential smoothing with alpha equal to 0.2 to forecast demand. The forecast for the first week of January was 400 units, whereas the actual demand turned out to be 450 units. See, the first week forecast is 400, but the actual demand is 450. That is the difference, right? So error has to be calculated. 450 minus 400 becomes 50. There is a difference of 50 error. So error has to be reduced. For that we have the exponential smoothing constant. If you multiply this smoothing constant with the error, there will be a reduction in the error part. The first question asked is A, forecast for the demand for the second week of January. So for the first week of January, actual demand and actual forecast has been given. You have to forecast the demand for the second week of January, and also the demands for different weeks has been given, subsequent weeks has been given. Forecast the demand up to February 3rd week, assuming the subsequent demands as 465, 434 and 460 units still so. So you have to predict this forecast based upon the exponential smoothing method. The formula that has been given here is, so Ft equal to Ft minus 1 plus alpha into dt minus 1 minus Ft minus 1. So this portion is the error calculation. So if you multiply this with the alpha, then the error comes down, okay, and this already forecast you have to add it up so that the error comes down. So F2, if you calculate for the second week, here is a simple calculation is given. So if you take the first row, the demand for the January first week is 450 and the old forecast is 400. So you have to calculate the error. So forecast error is dt minus 1. So this portion is the error calculation, dt minus 1 minus Ft minus 1. The formula also given here. So 450 minus 400 becomes plus 50. So we have to correct this error because there is a deviation of 50. So alpha is 0.2 as given in the formula. So 0.2 into 50 becomes 10. So if we add this correction with the old forecast, so 400 plus 10 becomes the 410. So this forecast has to be written over here for the second week. So actual demand has been given in the question as 460 and 410. Here the forecast error is 460 minus 410. Against the forecast error becomes 50. You have to multiply it with the smoothing constant to reduce the error. So it becomes 10. So 410 plus 10 is equal to 420. This you have to write it here for the next week. 420, the actual demand is 465. So 465 minus 420 becomes 445. So multiply it with a factor 0.2. So that becomes 9 over here. So the 9 plus 420 becomes 429. So this forecast has to be written against the week 4, and 434 minus 429 is 5 multiplied by 0.2 becomes 1. So 429 plus 1 is 430. So this 430 has to be written against the February week 1, that is the 430. So 420 minus 430 becomes minus 10. So 0.2 into 0.2 becomes minus 2. So 430 minus 2 become 428. This 428 has to be written against the week 2, and 498 minus 428 becomes 70. So for you have to add it up like the minus, you have to subtract it into 0.2, that becomes 14. So 428 plus 14 becomes 442. This 442 has to be written against the old forecast against the week 3 of the February, and 462 minus 442 becomes, this you have to subtract, and 420, so into 0.2. So wherever the error has to be multiplied in all cases with 0.2, get the value of 4, and 442 plus 4 becomes 446. So this is how we are going to calculate the exponential smoothing constant method. New forecast has been predicted, whereas in the past two methods we don't predict the new forecast, only we retain with the old forecast. We have to calculate the error, and we have to correct the error, and new forecast has been predicted. Or if you can see that there is always a difference between the old forecast and the new forecast, because we are doing the smoothing here, to avoid the errors. So that's all, we came to the end of the lecture. Today we have covered about the forecasting models and the time horizon of the forecasting, and the different types of forecasting such as qualitative and quantitative methods, and we have solved some numerical problems under quantitative methods. Thank you for listening to this lecture. Good day.